In this lab, we'll be learning some concepts and practical skills for administering the YMCA submaximal aerobic capacity test. After completing all of this lab, you'll be able to know why this test is conducted, you'll be able to know what equipment is needed, and you'll be able to demonstrate the proper techniques and procedures for conducting this test and for interpreting the data. The YMCA submaximal exercise test predicts VO2 max. Since we assume there is a linear positive relationship between heart rate, workload, and VO2, which is oxygen consumption, if we know two of the three variables, then we can predict the third. In this case, we know workload and heart rate, thus we can predict VO2 using the regression line made from the heart rate response to workload. We use this test to identify a maximal MET level for the patient in order to accurately prescribe activity and exercise. While the best determinant of VO2 max is a graded exercise test to exhaustion, time, patient health, cost, or other factors may not give us this opportunity, and so we can use a submaximal test. We just need to be aware that the accuracy is reduced, but it still gives us a starting point for prescribing aerobic activity for our clients. Since the modality of exercise for most people is walking, testing on a treadmill is preferred. However, if clients have limitations that would keep them from walking at the speeds needed for the Bruce single stage, then the YMCA or other cycle ergometer protocol can be used. In order to conduct the YMCA test, you'll need a stationary cycle ergometer that can provide resistance in units of 1/2 kilogram up to 3.5 kilograms. If your cycle ergometer does not have an RPM dial, you'll also need a metronome for the client to help keep cadence. Heart rate monitors are optional, and while often used in the clinical setting, we'll be learning to take exercise heart rates with the radial pulse. You will have learned this in the heart rate tutorial. You'll also need a rating of perceived exertion scale. The Borg 6-20 scale is commonly used, a blood pressure cuff, and a timer. You can use any kind of timer. The one on your phone works nicely, or you can use the time if it's displayed on the stationary bike. This is a workload flow for the YMCA protocol. There's another workload flow that uses 4 columns that represents different workloads based on different heart rate responses, and those will be used in our scenarios. But for now, so that you know there are 2, we'll use this one. Once you understand the diagram, it's very easy to follow. First, note the starting resistance. It's 1/2 kilogram. And when the test is ready to begin, this is the resistance to be used. Clients will be pedaling at a rate of 50 RPMs throughout the test, and this does not change. And each stage is 3 minutes, and that doesn't change either. After stage 1, the load you apply depends on the client's heart rate. For example, if the client's heart rate is less than 86 beats per minute, you'll have to bring up the resistance to 2 kilograms. If it's between 86 and 100 beats per minute, you'll have to bring it up to 1.5 kilograms. And if it's over 100 beats per minute, you'll just bring it up to 1 kilogram. So let's say after stage 1, your client's heart rate is 94 beats per minute. How much resistance would you add? If you said 1 kilogram, you're right. Since there was already a 1/2 kilogram resistance on the first stage, and at the end of that stage our client's heart rate was 94, we would have to add 1 kilogram to bring up the resistance to 1.5 kilograms. We move forward now to the end of stage 2, and suppose our client's heart rate is 121. The resistance now is 2 kilograms. Some of you may have said 1.5 kilograms, since heart rate was now above 100, and this brings up to a common mistake many students make when following this protocol, which is they switch columns. Once you establish your resistance for the second stage, don't ever switch columns. You will see between stages 2 and 3 and 3 and 4, there is a 1/2 kilogram increase in resistance no matter what column you're in. So after stage 2, everyone increases resistance by 2 kilograms no matter what column they're in. In the YMCA protocol, we need steady state heart rates from 2 stages in order to calculate estimated VO2 max. These steady state heart rates must be between 110 and 70% of heart rate reserve or 85% of age predicted heart rate max. General rule, as a lot of scholars follow, is no more than 150 beats per minute. Well, at our first stage, heart rate was 94 beats per minute, which is lower than the 110 beat per minimum, so we can't use that one. But our second stage heart rate was 121 beats per minute, which is between the low and the high limit for that heart rate, and so now we proceed to stage 3. We already identified our resistance for stage 3 of 2 kilograms. After 3 minutes of pedaling at 50 RPMs, our client's steady state heart rate is now 137 beats per minute. What do you think we do now? Well, we're finished since we already have steady state heart rates from 2 consecutive stages between 110 and 150. This is an example of what data collection sheet might look like. The YMCA protocol requires the administrator to collect heart rates during the last 15 to 30 seconds of each minute and blood pressure and RPE at the end of the 3rd minute of each stage. Ultimately, we must have steady state heart rates between 110 and 150 beats per minute from 2 consecutive stages. Now note, this is not a single stage protocol as you will or have learned with the Bruce submaximal test. Again, the YMCA requires the client produce steady state heart rates between 110 and 150 beats per minute from 2 consecutive stages. Steady state is defined as no more than a 5-beat difference between minutes 2 and 3 of a stage. And why does it have to be between 110 and 150 beats per minute? Think about cardiac output. What are the 2 main components of cardiac output? Heart rate and stroke volume, right? In general, both heart rate and stroke volume contribute variably to cardiac output when heart rates are lower than 110. Once heart rate reach 110 beats per minute, their contribution to cardiac output is near maximal, and further increases in cardiac output are made mostly by increases in stroke volume. Now let's say heart rates during the first minute of stage 1 was 89, minute 2 was 92, and minute 3 was 94. Is that steady state? It is within the 5-beat minimum, right? But if it's not steady state, then we need to extend the stage by another minute. After which we will measure heart rate again, then measure blood pressure and ask for RPE. We know that since steady state heart rate is below 110, we cannot use this data point, but since we are in steady state, we increase resistance as discussed on the previous slide. And in minutes 1, 2, and 3 of the second stage, we have heart rates of 105, 119, and 121 beats per minute. Here, looks like we're in steady state since 119 and 121 are within a 5-beat range. And 121 is between 110 and 150 beats per minute. But we still need another steady state heart rate between 110 and 150, so we proceed to stage 3. In minutes 1, 2, and 3 of stage 3, we have heart rates of 128, 135, and 137. Since there's a 2-beat difference between 135 and 137, and since 137 is between 110 and 150, we can also use this as our second data point. Now there's no need to continue, and it's also stated that we should not proceed to the next stage if heart rates are above 135 at the end of a given stage. We now have the 2 data points needed to estimate VO2 max, and again notice they come from 2 consecutive stages. You may have clients who only reach steady states between stages 1 and 2, and you may have clients who are so fit they will proceed all the way to stages 3 and 4. What I'm giving you here is just a fabricated scenario. Before leaving this slide, you may also be thinking about blood pressure. While this RPE is used to estimate VO2 max, blood pressure is taken to make sure there are no general indications for stopping an exercise test. For example, if systolic blood pressure drops 110 millimeters of mercury or more when work rate increases, if it goes above 250 millimeters of mercury at any point, and or if diastolic pressure rises above 115 millimeters of mercury, the test should be stopped immediately. Now we can put our work on paper. This is the grid used to estimate VO2 max during heart rates from the YMCA protocol. Before we do, let's make sure we understand our units of measure. We learned what resistance to use for our clients when they were on the bike. What we need to do now is understand workload. Workload on the stationary bike is made of three things: resistance, pedal rate, which is also revolutions per minute, RPM, and the distance traveled in one pedal revolution. On the Monarchs, we use the distance traveled in one pedal revolution is 6 meters, such that if the bike was on the ground and you made one revolution, you would travel 6 meters. We know they are pedaling at 50 RPMs. And we also know the resistance. If we multiply all three of those, then we get workload. For example, the initial workload will be the same for everyone, which is 150 kilogram meters per minute. It is simply 50 RPMs times a half a kilogram times 6 meters. Based on our client's heart rate from this first stage, we had a resistance of 1.5 in the second stage, pedaling at 50 RPMs times 1.5 kilograms times 6 meters, which is 450 kilogram meters per minute. And our final stage was 50 RPMs. We went up another half a kilogram, right? So 50 RPMs times 2 kilograms times 6 meters is 600 kilogram meters per minute. Remember, we can't use stage 1 since heart rates were below 110 beats per minute. So we go to the workload stage of 450 and 600 kilogram meters per minute. At 450 kilogram meters per minute, our heart rates were 121 beats per minute. And at the 600 kilogram meters per minute workload, our heart rate was 137 beats per minute. We then use 220 minus age to predict estimated heart rate max, and let's say our client is 25 years old, so our estimated heart rate max is 195 beats per minute. There are issues with using this formula, but those are discussed in our lectures, and we will use the 220 minus age for now. We now draw a line through the two heart rates to the top of the estimated heart rate max, and from that intersect, draw a line straight down vertically. This shows us our client has an estimated maximal workload of about 1,125 kilogram meters per minute, and if we divide that by 6.12, we get 184 watts, since there are about 6.12 kilogram meters per minute in 1 watt. Our client's predicted VO2 max is 2.6 liters per minute. And if we convert this to a relative measure, we simply change liters to milliliters by multiplying 2.6 times 1,000, since there's 1,000 milliliters in 1 liter, and then dividing by body weight. So let's say our client weighs 70 kilograms. Estimated VO2 max in absolute units is 2.6 liters. Multiply that by 1,000, and then divide that product by his body weight in kilograms. So we have an estimated relative VO2 max of 37.1 milliliters per kilogram per minute. You'll be learning more about absolute and relative measures of VO2 max in our lectures. Finally, we can estimate maximal MET level. 1 MET is equal to 3.5 milliliters per kilogram per minute. So if we just divide our client's estimated relative VO2 max by 3.5, we have an estimated maximal MET value of 10.6. So this now gives us information to help prescribe exercise intensity for our clients. So now that you understand the basics of the YMCA submaximal cycle ergometer test, time to watch the videos and look at the scenarios.